Good morning children, welcome back to maths class. In today's class we continue the same chapter playing with the numbers. So children, in the last class we discussed a few questions from exercise 3.5. So remaining questions we discuss in today's class. I hope everyone practiced more questions. Not only that exercise questions, more questions you have practiced and studied. Okay. So today we continue 5 questions we completed in the last class. Now we start from question number 6. Okay children, open a textbook and write down question number 6. Exercise 3.5, question number 6. Okay. Find all the prime factors of 1729 and arrange them in ascending order. Now state the relation, if any, between two consecutive prime factors. Okay. The given number is 1729. They asked you to write the prime factorization. Now you know how to write the prime factorization, right? We studied in the last classes. Yes or no? Yes. So 1729. So first we will find out the prime factorization of 1729. Okay. Can you divide this number by 2? Children, tell me, can you divide this number by 2? No, it is not possible, right? Can you divide by 3? Let us take 9 plus 2, 11, 18, 19. No, it is not divisible by 3 also. Can you divide by 5? Impossible, because one's place is 9, right? What's the divisibility test for 5? Either 0 or 5 should be there in one's place. Here 9. So, what is the next possibility? 7. Okay, let us take 1729 divided by 7. 7 2s are 14, 3, 32, 7 4s are 28, 4, 49, 7 7s are 49. Yes, it's divisible by 247. 247 is not a prime number, right? 247 is not a prime number. Again, can you divide this number by 7? No, 2 7 3s are 21. 37 is not divisible by 7. Next term, after 7, which is the next prime number? 11. Can you divide by 11? No. 11 2s are 22. No, it's not possible. Next, which is the next possibility? 13. Let us take 247 divided by 13. 13 ones are 13. Can you take 2 times? No. So 7 plus 4, 11, 117. 13 9s are 117. So 13, 19s are 247. 19 is a prime number, so we'll stop. Now one more question they asked. What is the relation between these prime factors? Right? What is the relation? Now look at here. 7 plus 6 is 13, right? 7 plus 6 is 13. What is 13 and 19? What is the difference between 13 and 19? 13 plus 6 is 19. So what is the relation between these prime factors? Difference between consecutive prime numbers is 6. What is the relation? Difference between the consecutive prime numbers is 6. Okay. So prime factorization of 1729 is 7 into 13 into 19, and the relationship, the difference between consecutive prime numbers, difference between consecutive prime numbers is 6. In bracket you can write 13 minus 7 is equal to 6. Next, 19 minus 13 is equal to 6. Okay. The difference between consecutive prime numbers is 6. Okay children? Yes. Now, the next question, question number 7. The product of three consecutive numbers is always divisible by 6. Verify the statement with the help of some example. The product of three consecutive numbers. Any three numbers you can take, counting numbers. But cannot take 2, 5, 7 like this. How the number should be? Consecutive numbers. Any three numbers you can take. 1, 2, 3. Let us take 1, 2, 3. 1, 2 and 3. Product. 1 into 2 into 3 is 6, right? Yes, 6 is divisible by 6. Take any other number. 4, 5 and 6. 4, 5 and 6. Multiply. 4, 5 and 6. What is the product? 4 into 5. 4, 5s are 20. 20 into 6. 20 into 6 is 120. Yes, 120 is divisible by 6, right? Let us check. 6 2s are 12. Yes, 6 20s are 120. Right? So no. Like this you can take any three numbers, any three consecutive numbers. When you multiply, the product is always divisible by 6. Okay. So write down. This answer. The product of any three consecutive numbers always divisible by 6. For example, 1 into 2 into 3 is equal to 6, divisible by 6. Next, 4 into 5 into 6. 4 into 5 into 6 is 120. Divisible by 6. Okay, like this you can add a few more examples here. Okay, take three consecutive numbers, find out the product and check the number is divisible by 6 or not. Okay, children? Yes. Now, the next question, question number 8. The sum of two consecutive odd numbers is divisible by 4. Verify the statement by the help of some example. So, what is the next one? The sum of consecutive odd numbers. So, tell me children which are the odd numbers? 1. The first smallest odd number is 1. Next to 3. Next 5, 7, 9, 11, 13. 15, etc. These are odd numbers, right? So, this is a question. Add two odd numbers, consecutive odd numbers. The sum is always divisible by 4. Let us check. What is 1 plus 4? For example, 1 plus 4. So, 1 plus 3 is 4, right? 4 is divisible by 4. Now, take these two. 3 and 5. 3 plus 5. 8. Yes, 8 is divisible by 4. Take next 5 and 7. 5 plus 7. 12. Yes, 12 is divisible by 4. 7 plus 9. 7 plus 9. 16. Yes, 16 is divisible by 4. All these numbers divisible by 4. Okay, can you write the answer? Write down. First to write a few odd numbers. Odd numbers. Question number 8, right? Odd numbers. Write 1, 3, 5, 7, 9, 11, etc. Okay, add them and write this. Okay. So what is our answer? Sum of consecutive odd numbers. All numbers always divisible by 4. Sum of consecutive odd numbers always divisible by 4. Okay. And the next one, in which of the following expression prime factorization has been done? That's easy one, right? Now look at the first one, 24. 2 into 3 into 4. In prime factorization, there should not be any composite numbers, right? But in the first question, there is a composite number. So the prime factorization is not done. Second 56, yes, 7 into 2 into 2 into 2, yes. Third one, 70, 2 into 5 into 7, yes. But fourth one, 54, 2 into 3 into 9. 9 is a composite number. So prime factorization is not done. So which is the answer? The correct one, B and C. Question number 9. The prime factorization is done properly in B and C. Okay, so A and D are wrong. Now the next question number 10. Determine if 25,110 is divisible by 45. Okay. One hint is given, 5 and 9 are co-prime numbers and the test of divisibility of 5 and 9. Test the divisibility of 5 and 9. Okay. Given number 25,000. Question number 10. 25,110. Okay. In divisibility test, we studied that the special divisibility test, some more divisibility tests we studied. If a number is divisible by two co-prime numbers, okay, if a number is divisible by two co-prime numbers, okay, that number is also divisible by their product. Number is divisible by two co-prime numbers, the number is also divisible by its product. Here the given number 2545 is divisible by 45. Is divisible by 45, right? But 45 is divisible by 5 and 9. And what are these 5 and 9? 5 and 9 are co-primes. 5 and 9 are co-primes. So 5 into 9 is 45. If two numbers are divisible by the co-primes, the number is also divisible by its product, right? 5 and 9, 45 is divisible by 5 and 9. 45 is divisible by 5 and 9. Or 45 is divisible by 2110. Okay. Right. First we'll check this. 25,110. 25,110 is divisible by 5. 25,110 is divisible by 5 because 1's place is 0. Now add the digits 2 plus 5, 7, 9, 7, 8, 9. 2 plus 5 plus 1 plus 1 plus 0 is 9, right? So 25,110 is divisible by 9, right? The sum of the digits is a multiple of 9, so the number is divisible by 9. So therefore 25,110 is also divisible by 5 into 9, 45, because 4 and 5 are co-primes. Okay, children, 4 and 5 is not 4. 5 and 9, right? 5 and 9 are co-primes. 5 and 9 are co-primes, and the given number is divisible by the co-primes. And we studied that if the given number is divisible by co-primes and the number is also divisible by their product. What is 5 into 9? 45. So what is the answer? 25,110 is divisible by 45. Okay. Now the next 18 is divisible by both 2 and 3. It is also divisible by 2 into 3, 6. Similarly, a number is divisible by both 4 and 6. Can we say the number must also be divisible by 4 into 6, 24? Is it possible, children? In the first case, 18 is divisible by 2 and 3. Okay, 2 and 3 are co-prime numbers, right? So we can say the number is also divisible by their product. Then what is about the next one? One number is divisible by 4 and 6. 4 and 6 are not co-prime numbers, right? 4 and 6 are not co-prime numbers. So the number is not divisible by their product. So the answer, what is the answer? 4 and 6. 4 and 6 are not co-primes. Co-primes. Therefore, the number is not divisible by their product. Product. What is a product? 4 into 6. 24. Okay. If they are co-primes, okay, the number is divisible by their product. The given numbers are not co-primes, so the number is not divisible by their product. Now, and the smallest number having 4 different prime numbers, can you find me? The smallest number with the 4 different prime factors. Which is that? Tell me, children. Think and find out the answer. The smallest number which is having 4 different prime factors. For that, you have to find out which is the first 4 prime factors. The first smallest prime factor is 2, right? Prime number, right? And the second prime number 3. And the next 5. Next 7. 2, 3, 5 and 7, right? 2, 3, 5 and 7. Find out the product. 2 into 3, 6. 6 into 5, 30. 30 into 7, 210. So what is the answer? The smallest number which is having 4 different prime factors is 210. Is that clear? Because they are the smallest number. So what you have to do? You have to find out the product of first 4 prime numbers. Okay, if they are same question for first 5 smallest number with having 5 prime factors, what you have to do? 2 into 3 into 5 into 7 into the next prime number you have to multiply. If there are 6, the first 6 prime numbers you have to multiply. Okay, children? Yes. So in today's class we discussed a few questions based on prime and composite numbers and prime factorization. I hope this is clear, and you get more questions in worksheet for your practice. Okay, children?